this video, we will classify magnetic materials into three: paramagnetic, diamagnetic, and paramagnetic. Okay, and we will also go into the detailed properties of these three types of magnetic properties. So first we will see diamagnetic substance. Now, diamagnetic substance are those substances when it is exposed in an external magnetic field that will create a magnetic moment inside. So magnetization will happen, but that will be opposite to the direction of external magnetic field, which means this is the external magnetic field. Say for example, now the top is north, say for example, so north, south. So when we are keeping an external magnetic field, a substance, we are expecting a substance to magnetize in the same direction. So south, north, south, north. So north will be head part, and here is also north is on the head part. Okay. Now this is what we are expecting, right? But actually the magnetization will be opposite to the direction. So what will happen? So let's say this is 100. Now if this is 20, the net magnetic field here will become 80. So that will reduce the total magnetic field in that space. So susceptibility is negative. We have learned it in the previous example because it is creating a magnetic moment in opposite direction. So what will be the effect of this when I am keeping a magnet in a magnetic field? Let's say, so now the material is inside the magnetic field is going in this way. So this material will rotate themselves and will try to go away from the magnetic field, which means from stronger magnetic field, it will move to a weaker magnetic field. Next example is this. We can get the powdered diamagnetic substance. Now, see, when two magnets are kept very close to each other, then their magnetic field lines will be this way, which means on the mid part we will be having the strongest magnetic intensity. On these 2 points it will be less, but at a distance away from each other it will be just the opposite. So this will happen only when they are very close to each other. Here will be the highest intensity, but when we are keeping a distance apart, then these poles will be the strongest point where we have the highest magnetic field. Okay, so here is the highest field here. In this case, here is the highest field here. So when we are expecting when we are spreading the powdered diamagnetic substance, we will see that the concentration of diamagnetic substances will be more here, and it will be less on the surface. Actually, when we are keeping an iron powder, it will be more at the place where the magnetic intensity is more, right? But here in this case, it will be less at the place where the magnetic field is more, and it will be more at the place where magnetic field is less. So here in this case, here it is weak, right? So powder will be more here. So that will be, see, particle will be repelled by stronger magnetic intensity. So this is a stronger intensity. So from here it will be repelled. So this will be the particle arrangement, diamagnetic. Now when I am keeping a diamagnetic substance here, the magnetic field line don't want to go through diamagnetic substance. That will go around it, because this doesn't like magnetic field line. Okay. Similarly, when you are keeping, so let's say I am taking a liquid diamagnetic substance, and if I am keeping it in a mercury, we are keeping a magnetic substance here. We are keeping a magnet here. So what will happen? This mercury level will fall down because it has to go away from the stronger magnetic field. Here it is stronger. So this liquid will go away from it. So that will dip down. In the case of paramagnetic substance, it is just opposite. And one more thing, we can't exactly say it is opposite. See, this substance has no magnetic field, doesn't have any magnetic moment by nature. But when we are keeping in an external magnetic field, it will create a magnetic moment opposite to the external magnetic field. But this substance, by nature, it has certain magnetic moments. So let's say these are magnetic moment inside a material. So one moment and another moment will cancel. Now this will be cancelled by this. Downward will be cancelled by upward. So there are some magnetic moments which are not cancelled. So this will sum up to create a small magnetic moment inside paramagnetic substance. So it will have magnetic property by nature. So the value, so this material when you are keeping in a magnetic field, this will develop more magnetization in the same direction. So susceptibility is positive. But now Curie has found a very interesting things about paramagnetic substance. Now paramagnetic substance has got some magnetic properties, right? They have magnetization in the direction of external field, or they have some magnetization. Now this magnetization will be reduced when we are increasing temperature. This is called as Curie's law in paramagnetism. As per Curie's law in paramagnetism, magnetization reduces with increasing temperature. This is the equation. So when T increases, magnetization decreases. So this can be connected with susceptibility. What will happen? Susceptibility decreases when temperature increases. And what is the reason for this? Now when temperature increases, these dipoles will get higher energy. So this will, randomly move at its position. So before, let's say, if three number of magnetic dipole moments are there at lower temperature aligned in this direction. But whenever we are increasing temperature, these magnetic moment will vibrate. So some of this cannot align in this direction. Let's say this is not able to align. This is now in this direction. So we have only two magnetic moments in the same direction. So what has happened? Higher the temperature, higher will be the energy for magnetic moment. So this magnetic moment cannot align themselves. That will create lesser magnetization, or that will be the reason for lower susceptibility. This is Curie's law in paramagnetism. Here in this case, it will be just the opposite. Same example. When I am keeping a red color. So inside a paramagnetic substance, when we are keeping in an external magnetic field, these external magnetic field lines will prefer to go inside or prefer to go through paramagnetic substance. It is the just opposite here. Magnetic field lines will never prefer to go through the paramagnetic substance, but here that will prefer. Now when I am keeping a magnet, now if this is a paramagnetic liquid, what will happen? That will be attracted. So that will go up. In the previous case, that will go down. So these are the examples. Compare. So comparison is very important. That's the reason I have put all these three together in the same video. Now next one is very, very important. That is ferromagnetic substance. Now here we are having individual magnetic dipole moment, right? So I have 1, 2, 3. They are aligned. Here you can see in ferromagnetic substance, we can see cluster of magnetic dipoles. So these are called as domain. This is the same thing. These are dipole moments created by one atom, another atom. So these are in the same direction. So there will be different direction as well. But see, the one which are in the same direction will form a domain. So this is not the magnet. So the whole thing is the magnet. Now we have one domain here. Similarly, at different place, another domain will be created. But here, the direction will be downward. Now here, there will be another domain created. The direction is leftward. But these domains can behave as individual magnet, right? So this domain will be an individual magnet where this is north and this one is south. From here, magnetic field lines will be outward. That will go to south. So inside the magnetic field, right, field will be going from south to north. So this one is south, this one is north. Now when there are individual magnets inside as domain, so this will rearrange themselves in this form. So this will rearrange. Now this north will be attracted by the south, and this south will be attracted by the north, and they will form a closed loop like this. North, south, this is one domain. Now north, south, another domain. North, south, another domain. So in this way, they will form a closed loop. But what is the problem here? Now the magnetic field lines are just going through inside. So for us to experience the magnetic field line, there will be some magnets which are open. So from there, we can expect magnetic field lines coming or going. But these magnetic field lines are residing inside. They are forming a closed loop inside, and they are circulating inside. We need open. So we have to basically break this closed loop formed by the domains. So once it is disintegrated, once it is opened, then we can expect domains in this way: north, south, north, south, north, south, north, south. Now from here we will get a bigger, very high amount of magnetic field at one end, but it has to be open. It should not be closed in this way. So when we are keeping in an external magnetic field, that magnetic field will give them energy or will force them to rearrange themselves in this form. So that will create a very high magnetic field outside. So here susceptibility is positive, but here it is positive and very high because it's just individual dipole moment. But here individual dipole moment will form cluster or domains, and these domains will align themselves to create a substance with higher magnetic field. Okay, so these are ferromagnetic substances. Now, see here, Curie has told when we are increasing temperature, its magnetic susceptibility and magnetization will reduce. But here, when we are increasing temperature, what will happen? Same thing that will happen. So I will read the definition. Curie's temperature is the temperature at which ferromagnetic material will disintegrate and become paramagnetic material. So ferromagnetic material has got high susceptibility. This has got low susceptibility. It can come from here to here when at Curie's temperature. So you can increase the temperature, and beyond a certain limit, its ferromagnetic behavior will completely change into paramagnetic behavior. So explanation is the same. Higher energy for the domain, so that won't arrange themselves in a proper order. So the susceptible magnetization will decrease. On decreasing and decreasing and decreasing, its value will become paramagnetism. But you can easily give the definition in this way. Ferromagnetism is nothing but, Curie's temperature is nothing but a temperature at which ferromagnetic behavior will be converted into paramagnetic behavior. Now, after that, when you are increasing temperature, it's the same thing that has happened here. What will happen? After Curie's temperature, when we are increasing temperature, then again susceptibility will decrease. So, at Curie's temperature, ferromagnetic substance will be converted as paramagnetic substance. Now, once it is converted as paramagnetic substance, still it is ferromagnetic substance, right? For example, iron is a ferromagnetic substance. Now, its ferromagnetic behavior will be changed to paramagnetic behavior. And after, still if you are increasing the temperature, what will happen? This is the equation. So, increase the temperature. So, higher, see, this is Curie's temperature, Tc. This one is constant. So, higher the temperature, increasing temperature, the denominator will be higher. So, the total value will be lesser. Susceptibility, what will happen to the susceptibility? That will decrease. So, I'll explain the concept once again if you got confused. Paramagnetic and ferromagnetic has got this susceptibility value positive. But here it is less, here it is very high. Now, ferromagnetic substances will behave as paramagnetic substance at a temperature called Curie's temperature. So, after increasing the temperature, this will happen. That will behave like paramagnetic substance. Again, if you are increasing temperature, what will happen? Its susceptibility will decrease. So, this is one equation, and the next thing is the definition for the Curie's temperature. Now, Curie's law has been defined here. That is this one. Increasing temperature, susceptibility will decrease. This is very, very important. So, we will conclude everything. In diamagnetic substance, it will move from stronger magnetic field to weaker magnetic field when it is placed in an external magnetic field. Okay, so when external magnetic field is provided, this will create a dipole moment which is opposite to the direction of external magnetic field. So total magnetic field inside, that will be reduced. I have explained it with number. Here in this case, it has got net magnetic dipole moment, though we are not giving external magnetic field. So it has, by nature, it has got certain magnetic properties, or it has net magnetic moment. Now when it is placed in external magnetic field, it will build more magnetism by keeping these magnetic moments aligning in a particular direction. Okay, so anyway, paramagnetic substances will move from stronger magnetic field to weaker magnetic field. So susceptibility is positive here. So when it is placed in an external magnetic field, it will increase the total magnetic field. And when temperature increases, susceptibility decreases or magnetization decreases. Curie's law. Very important. In the case of ferromagnetic substances, see, the only difference here is we have, see, what is the common thing here? I have magnetic dipole moment here and here as well. But the thing is, here magnetic dipole moment has formed a domain, and these domains are aligned in a direction when external magnetic field is provided. When it is not provided, that forms a closed loop, and its magnetic field is less, or I can say that it is very less, because they form closed loop internally connecting with themselves. But when we are providing an external magnetic field, they will be aligning in the same direction to give a very high amount of magnetic field inside. So here it is only dipole moment, but here dipole moments forms a domain, and these domains are connected in the same direction or aligned in the same direction to give a larger amount of magnetic field here. So here what happens is, when temperature increases, ferromagnetic substance will behave as paramagnetic substance, that is this one. That temperature is Curie's temperature. Now after Curie's temperature, still if you are increasing temperature, its susceptibility decreases. This equation is very important. So that is the difference in between paramagnetism and ferromagnetism. So in short, I can say that this one is just a chota bai and this one is bada bai. So same thing almost, only when you are describing about this one, domain have to be there. Here magnetic moments, that's all. And one more thing, for iron, 1043 is the Curie's temperature. Above this temperature, this will behave as paramagnetic substance. And still if you are increasing the temperature, what will happen? Susceptibility will start decreasing. That's all. Thank you.